In this video, I'll be going through question 12 from the 2014 exam. This question involves sensitivity analysis, and you'll have almost all the information you need to do it on the formula sheet. It's just a matter of remembering the notation involved. I've put the relevant section from the formula sheet here. You'll have to remember what each of the letters denote, because they're not defined on the formula sheet. We have CI referring to the cost coefficients, and BI referring to resource coefficients. Moreover, the letters F, E, K, and B star appear. They correspond to values taken from the final tableau, which I've drawn in generality on the right here. I'm not going to explain the details of the table. You'll see where each part comes up as I go through the question. In part A, we're asked to find the allowable increase and allowable decrease for some cost coefficients so that the coordinates of the optimal solution don't change. This is covered by the first part of the theorem. You can see from the statement of the theorem that we're going to need two pieces of information. Firstly, to find the increase and decrease for the cost coefficient CI, we need to know whether the corresponding variable xi is basic or not. Xi is a basic variable if it appears in the leftmost column of the tableau. Once we know whether it's basic or not, we know which part of the theorem to use, and then we need to know certain values of E and F in order to do the calculation. F refers to the bottom row of the final tableau, except for the last value. The first value is F1, the second value is F2, the third is F3, and so on. E refers to everything else above that. EJK refers to the value of E at the jth row in the kth column. Now let's see this in action. We're first asked to find the increase and decrease for C1. So, in the statement of the theorem, we have I equal to 1, and so we have to know if x1 is a basic variable or not. We can see that x1 does appear in the left-hand column, so x1 is a basic variable, and we use the second part of the theorem. x1 appears in row 1, and so this is the row we're interested in. Namely, we have for row j, that j is equal to 1. Now, to calculate the allowable increase and decrease, we are required to find the minimum value from a set of numbers which we have to calculate. For the increase, we only pay attention to the numbers in this row, which are negative. And then we calculate this corresponding fraction. There's only one negative number in this row, which I've circled here, and that's the value of E. The corresponding value of F is the value down here that appears directly below it. So, for part A, the allowable increase is the minimum of 2 divided by minus 1, which is just 2. The calculation of the minimum itself was superfluous. Because there was only one value, we could have written that down straight away. For the decrease, we look at a similar set of values. We focus on the case where the numbers are greater than 0, and, this is very important, where k is not equal to I. What this means is we exclude the value E11, which is this value here. Now, we have two values which are greater than 0, this one and this one, and the corresponding values for f are taken from here. So, the allowable decrease is the minimum of 7 on 2 and 6 on 7, which is 6 on 7. Now let's do the same thing for C3. We first have to decide if x3 is a basic variable. And it is, and so we're going to focus on the third row of the tableau. To find the allowable increase, we look at the negative numbers in this row. There aren't any here, so there are no candidates for the set of values we're taking. In other words, the allowable increase is the minimum of nothing, which we define to be infinity. There is no restriction on the allowable increase for C3. For the decrease, we look at the positive values, excluding the value E33. So the allowable decrease is the minimum of 7 on 8, 6 on 5, and 2 on 3. Which is 2 on 3. This finishes part A, so let's move on to part B. For resource coefficients, we use the second part of the theorem. This time we don't have to worry about whether a variable is basic or not, but we do have to pay attention to which part of the table we use. The values for k depend on what our slack variables are. Our slack variables are S1, S2, and S3, so the matrix K is the part of the tableau here that appears underneath S1, S2, and S3. The values of B star come from this rectangle here, where the first one is B star 1, the second is B star 2, and the third is B star 3. In order to find the allowable change for Bi, we have to look at the ith column of the blue matrix. So, for B1, we have to look at the first column, once again, we're interested in whether a value is negative or positive. For the increase, we range over all the negative values, which is this one only. And then we take the corresponding value of B, which appears over here, and then calculate the corresponding fraction. Since there's only one negative value, we only have one thing to worry about, and the allowable decrease is just 5 on 3. For the decrease, we look at the positive values. That's this one here and this one here. And then the corresponding values of B star are taken from here. So the decrease is the minimum of 4 on 7 and 2 on 5, which is 2 on 5. We repeat the same process for B3. We look at this column and observe that there are no negative numbers. So the allowable increase is the minimum of nothing, which once again is defined to be infinity. For the allowable decrease, we look at all the positive values, which there's just one. And so we have the minimum of 5 on 1, which is just 5. And this finishes the question.